Good morning and welcome back, friends. We are still in the Java scenario. Today we are uploading Java programming part 15 of 33. Java programming part 15 of 33. So far we have uploaded Java programming up to part 14 of 33. So today we are uploading Java programming part 15 of 33. This is a very important video. This is a very important video in the sense that in this video we are actually introducing the concept of classes and objects. The concept of classes and objects, which is the heart and soul of Java language. So Java language started its life as an object-oriented language, unlike C++. In the case of C++, it was C who got graduated to C++, in the sense that C was made into object-oriented language and they called it as C++. So it was a gradual gradation from procedure-oriented language to object-oriented language in the case of C++. Whereas Java started its life as a fully object-oriented language. Java doesn't have any procedure-oriented approach at all. Everything in Java is related to classes and objects. It's a fully object-oriented language. And for an object-oriented language, classes and objects are the heart and soul of the language. It is the heart and soul of that particular language. If it is a object-oriented language, classes and objects. Classes are the blueprints. In fact, they actually is the shape and nature of the object. They decide the shape and nature of the object. So we call an object as an instance of a class. An object is called an instance of a class. So classes are the soul of Java language. And objects are nothing but instances of classes. So we give a detailed description of classes and many examples from objects we are dealing. Next, another important point is the declaration of an object. How exactly we are able to declare an object in Java. Look, the moment we create a class, it becomes a user-defined data type. It becomes a user-defined data type. Unlike in C++, see, in the case of Java, you have to use the new operator in order to create an object. In order to create an object, you have to use the new operator. With the help of the new operator only, we are able to create an object in Java, unlike in C++. In C++, we don't want that. But in Java, we definitely need the new operator in order to create an instance or an object from a class. Okay, now look, another important aspect of the Java language is the introduction of a class contains these variables as well as functions or methods. See, behavior as well as these methods. So it's a combination of data and functions. Any class is a combination of data and functions. Normally in Java we call functions as methods. So methods have got a lot of importance. See, methods have got a very huge role in Java language. So we introduce the concept of methods also into the classes in this video. And finally we touch the so-called concept, namely the constructor. A constructor is used to initialize an object on creation. As soon as an object is created, it is the constructor which initializes the object. So constructors are also introduced in the beginning. So the beginning part of constructors are also introduced in this. So it's very important. Any video, you please go through it in great detail and without missing any single slide, because we are actually starting the heart and core of the Java language. Fine, good luck. We will go into the details of the video. Coming to part 8, introducing classes. We are now going to discuss the concept of classes in detail. Introducing classes. The class is at the core of Java. It is the logical construct upon which the entire Java language is built, because it defines the shape and nature of an object. As such, the class forms the basis for object-oriented programming in Java. Any concept you wish to implement in a Java program must be encapsulated within a class. It must be encapsulated within a class. Look, perhaps the most important thing to understand about a class is that it defines a new data type. Once defined, this new type can be used to create objects of that type. Thus, a class is a template for an object, and an object is an instance of a class. An object is an instance of a class. When you define a class, you declare its exact form and nature. You do this by specifying the data it contains, and the functions that operates on that data. Yeah, a simple class. We are now coming out with a small example from class. A simple class. Let us start our study on classes with a simple example. Here is a class called box that defines 3 instance variables: width, height and depth. See, class box. We use the keyword class, then the name of the class box. Next line, open the brace. Double the data type, double width, semicolon. Next again, double height, semicolon. Again, next, double depth, semicolon. Close the brace. This is a simple definition of a class. See, here it is named box. Class box. It has got 3 instance variables of type double width, double height, double depth. Close the brace. That's it. See, the box class. We are now describing the box class. Look, as stated, a class defines a new data type, in this case, the new data type is called box. You will use this name to declare objects of type box. It is important to remember that a class declaration only creates a template, it does not create an actual object. To actually create a box object, you have to use a statement like the following. Look, box, this is the data type box. My box, the instance variable, or in the instance, we call it as an object. My box is equal to new box. See, we are using the keyword new and then box and keeping a pair of parentheses like this. Actually, this is called the constructor. We will come to that later. Now, for the time being, you just look at the syntax. Box, my box, the instance or the object of type box, is equal to new box. Put a pair of parenthesis like this, then put semicolon. See, this creates a box object called my box. That's it. It creates a box object called my box. Now look, next. In order for the box object my box to get assigned with a specific value for any of its instance variable, comma, we use the dot operator as under. We use the dot operator as under. Look. My box dot width is equal to 100 semicolon. My box dot width is equal to 100 semicolon. Now the value 100 is assigned to the width attribute of the box object my box. Here is a complete program that uses the box class. Now we are discussing a complete program that uses the box class down. We are now coming out with programs from classes. We are now introducing the concept of classes and objects. Look, here we have created a new package. Look, my package is 06. For these programs, we have now created a new package by name my package is 06. Do you know the process of creating a new package? Just to go to this folder 1, right click, go to new, come down to package. See, yeah. So our package name I have given as my package is 06. So whatever name you want, you give here. So you can see source folder 1. See, it is 1. Source folder is 1. Look, it's our source folder is 1. So whatever name you want, you give. I have given, see, my package is 06. Just give the name, that's all. Oh, you just close it. I have just, you know the process, but still I am just reminding you. Close. So now we have created the new package by name my package is 06. And you know the process of creating a new class in a given package. Right click, go to new, come down to class. Look, this window will come. You just mention the name of the class. I have given the name box demo. Here you can just put box demo or whatever name you want you give. Then see that you don't forget to click this public static void main string args. This also you have to click. You know this process is well known to you. I was just reminding you for 1 second. Finished. I am just cancelling it. Okay, fine. That is how we are creating a new class in a given package. Okay, now we will come to the program. Look, it's a very simple program. Now look, package, my package is 06, semicolon. Next, a program that uses the box class. A program that uses the box class. The class that contains the main should appear at the top of the file. The class that contains the main should appear at the top of the file. See, this is actually the class box demo. So which contains the main. So that has come as the top. Look. Okay, that is normally the practice. Look. Call this file as boxdemo.java. What is it? Boxdemo.java. What does it mean? Boxdemo.java. That means you are going to create a class by name boxdemo. So that's it. Public class boxdemo. You know the creation of a new class in a given package. Okay. So we have now created this class public class boxdemo. Next line, open the brace. After that, we are now calling the main function. Public static void main in bracket string args close the bracket. So now we are now, as I told you, the box class is already here. This is the box class. Class box. This class declares a box type. Keep this class like this in the same file. You have to keep the class file like this in the same main file. Main, see, this is our main program, static void main. So in the file where we have the main program, main function, keep the class also like this. This class file should be in the same file. Class box, open the brace, double width, semicolon, double height, semicolon, double depth, semicolon, close the bracket. So this is the box class. This is the box class. Okay. Now, so public static void main string args, open the brace. Now we are using that box as the data type, box. My box is equal to new box, semicolon. Look, this is exactly how we are creating a new box object. So the name of the box object is my box. The my box object is now created using this particular syntax. It's very important to observe. See the data type, box, then the object name, my box, then is equal to new. You are using the new keyword and then box. After that, you are keeping the parenthesis, a pair of parentheses like this. After that, semicolon. This is actually the box constructor. We will come to the concept of constructor later, but now for the time being, you see that it is actually the class and then followed by a pair of parentheses. Class name followed by a pair of parentheses. It's nothing but the constructor. So this is the syntax of creating a new class a new box class object. Our class is box. So the object name is my box. The my box object is created using this particular syntax or particular call. New box, this constructor. We are actually calling this constructor, semicolon. Next one value we have defined, double wall for volume. Double wall for volume. Okay. Then assigning values to my box as instance variables. Now you know from this class my box, it has got 3 instance variables. It has got a width, it has got a height, and it has got a depth. Okay, you know it. So now we have to assign values to that. You are using for that we are using the dot operator. I already mentioned that. So assign values to my boxes instance variables. So my box dot width is equal to 10 semicolon. My box dot height is equal to 20 semicolon. My box dot depth is equal to 15 semicolon. So the width part and the height part and the depth part of my box object is properly initialized with values like 10, 20 and 15. Fine. That's the meaning of it. The value 10 is assigned to the width part, the value 20 is assigned to the height part, and the value 15 is assigned to the depth part of my box object. See, my box is an object. My box object. An object of the class by name box. Okay, fine. Now look, it's a matter of computing the volume of the box. You know how to create the compute the volume. So volume is equal to my box dot width. My box dot width star my box dot height star my box dot depth. So it's nothing but width, height and depth multiplied. All these things are multiplied. So we will get the volume. My box dot width star my box dot height star my box dot depth semicolon. Fine. Now the volume is calculated. Now it's a matter of printing it. System dot out dot print line in bracket. Volume of the box is that much is within double quote plus vol, vol. Close the bracket, semicolon. So the volume is now assigned to this variable vol. Vol is of type double, no problem. So in the variable vol, we have assigned the volume which we got from this calculation, this multiplication of width, height and depth. Okay, very simple. System.out or print line in bracket, volume of the box is that which is with the double quote plus vol, close the bracket, semicolon. Then close the brace. That closing brace is for the main function, public static void main. So it's the closing brace for the main function. And next line, that is the closing brace for the definition of box demo class. The definition of box demo class comes to an end at this point. That means the program has come to an end. Now look, Okay, the program is not yet over because we have to now do the major thing. That is what? The declaration of the box type. Look, so I have put a comment. This class declares a box type. Full stop. Keep this class like this in the same file. Then we are declaring the box class. Class box, we are using the keyword class, then the name of the class box, open the brace, its instance variable with the type double width semicolon, double again height semicolon, double depth semicolon, close the brace. So the box class is fully defined here. It is this box class which we used in the main program, in the main function. Okay, it's very simple. It's all over. Now it's a matter of saving everything. And okay, we have saved everything and we just click this run button. See, volume of the box is 3000. Volume of the box is 3000. It's very simple. 10 into 20 into 15. So width into height into depth. That's it. Volume of the box is 3000.0 because it's of type double. So it's very simple. Our first program on classes has now come like this. Observe this program. Go through the programs 2-3 times. It will be very clear to you. Fine. I think we can now stop. We will now stop. Yeah. Declaring objects using the new operator. Using the new operator. Look, declaring objects. Yeah. As just explained, comma, when you create a class, you are creating a new data type. Actually, you are creating a new data type. You can use this type to declare objects of that type. However, obtaining objects of a class is a two-step process. It's a two-step process. First, you should declare a variable of the class type. This variable does not define an object. Instead, it is simply a variable that can refer to an object. Second, comma, you must acquire an actual physical copy of the object and assign it to that variable. That's why we are telling that it's a two-step process. You can do this using the new operator. You can do this using the new operator. The new operator dynamically allocates, that is, allocates at runtime, memory for an object and returns a reference to it. This reference is, comma, essentially the address in memory of the object allocated by new. This reference is then stored in the variable. Thus, in Java, all class objects must be dynamically allocated. Let us look at the details of this procedure. We have used a statement like this in our previous program. What is it? Box, my box is equal to new box. After that, we have kept a pair of parentheses, semicolon. Look, it's nothing but the constructor of the box class. The class box, the variable my box is equal to new box. This new box with a pair of parentheses after that is actually called the constructor. We will come to that in great detail later, but now you just keep it in mind. Box, my box is equal to new box constructor. Put a semicolon. Fine. Yeah. Using new operator. Look. Box, my box is equal to new box. After that, we are putting a pair of parentheses like this. Then semicolon. Look. Box, my box is equal to new box. Actually, it is the constructor. New box, then semicolon. This statement combines the two steps just described above. It can be rewritten like under to show each step more clearly. Look, box, my box, semicolon. Look, box, my box, semicolon. Declare a reference to object. We are now declaring a reference to object. Then my box is equal to new box, then a pair of parentheses like this. Allocates a box object. My box is equal to new box constructor. Look, it is nothing but the constructor, semicolon. Allocates a box object. The first line declares my box as a reference to an object of type box. At this point, my box does not yet refer to an actual object. The next line allocates an object and assigns a reference to it to my box and assigns a reference to it to my box. Full stop. After the second line executes, comma, you can use my box as if it were a box object. But in reality, comma, my box simply holds, in essence, the memory address of the actual box object. You may also observe the usage box, then a pair of parentheses like this. You may also observe the usage of box, then a pair of parentheses like this. This is nothing but the box constructor, about which we will discuss at length later on. We will have a very elaborate discussion on the constructor later in the course. Fine. Yeah, introducing methods to a class. Introducing methods to a class. Look, as mentioned in the beginning of these discussions, comma, classes usually consist of two things, comma, instance variables and methods. Instance variables and methods or functions. Methods are nothing but functions. The topic of methods is a large one, comma, because Java gives them so much power and flexibility. Java gives them so much power and flexibility. Look, next. Adding a method to the box class. We can add any method to any class, no problem. Look, here we are adding a method to the box class. Although it is perfectly fine to design a class that contains only data, comma, it rarely happens. It rarely happens. Most of the time, comma, you will use methods to access the instance variable defined by the class. In fact, methods define the interface to most classes. In fact, we can add methods to the box class that will help you to compute the volume of the box, etc. Look at the following example. Yeah, look at the following example. Yeah, in this box class, we actually modify the previous box by adding methods to it. So I have used a different name for the box class in this program. In this program, I have used a different name for the box class. Look, I am using my box for the box class because this class contains a method also. It is no longer the same box class. So I have used a different name for that. That's the reason why I have used a different name. Okay, fine. Now look. So we are using the same package, my package 06. For this program also we are using the same package, namely my package 06. You know the mechanism of adding a new class to a given package. The process is well known to you. I don't have to again and again explain it. Okay, fine. We will now come to the program. See, package, my package 06. Package, my package 06, semicolon. Then look, some comments I have put. We will go through that. This program includes a method inside the box class. This program includes a method also inside the box class. Yeah, as stated earlier, each object of a class will have its own copies of the instance variables. Obviously, each object will have its own copies of the instance variable. That's why one object is different from another object. Fine. This means that if you have two box objects, comma, each has its own copy of depth, width and height. Obvious. It is important to understand that changes to the instance variables of one object has no effect on the instance variables of another. You know that very well. The following program declares two box objects. Two box objects. Yeah, call this file as boxdemo2.java. Boxdemo2.java. So what does it mean? We are now going to create a class by name boxdemo2. Boxdemo2. Look. Then public class boxdemo2. Next line, open the brace. Now we are calling the main function. Look. Public static void main in bracket string args close the bracket. Next, open the brace. Now in this program I told you I am using a different box. See, a class is actually class my box. Look, the box class this time is my box. This box class is different from the previous program's box class because in the previous program's box class it has got only instance variables. There was no methods. But this particular box class has got method also. Look, this volume method is there. This volume function is also associated with the box class. So I have named it differently. See, my box. So that's okay. That's the reason why I have given a different name. If I am giving the same name, there will be conflict because we are using the same package. We are using the same package. Otherwise, if I have to use the same box name, I have to bring into a different package and put everything in that package. See, again, if for each program when I modify the box class, each time I have to use a different package. That's not needed. That's why I simply changed the name of the box class. I just changed the name of the box class so that everything can be associated with the same package. I am using the same package. You understand? See, I am using the same package. What is that package? My package 06. See, my package 06. Okay, fine. I think it's very clear to you. Now look. Okay, fine. Now public static void main in bracket string args close the bracket. Then open the brace. As I told you, we are now using the box as my box. The box class is my box. So my box 1 is equal to new my box, the constructor. Semicolon. Look, this my box, if you are keeping a pair of parentheses like this, it means it is the constructor. So my box is the class name. So my box 1 is the reference to the box class. So my box 1, it is being created because of the new operator, new my box, and we have kept this parenthesis, left parenthesis and right parenthesis, means it's nothing but the, so I will just call it as the constructor. I will tell you the exact meaning of a constructor, etc. later, but now you just believe my word, it is the constructor of the box class. Okay. So my box 1 is equal to new my box constructor, semicolon. Again, my box 2, now another object, my box 2 is equal to new my box, again constructor, semicolon. So two objects two new objects, my box 1 and my box 2, are created. Because of the new operator, we have created it. It's already. Objects are now available, physically available in memory. Now look, assign values to my box 1's instance variable. So my box 1, we are now going to assign with values. So my box 1 dot width is equal to 50 semicolon. My box 1 dot height is equal to 25 semicolon. My box 1 dot depth is equal to 10 semicolon. So now we have initialized my box 1 object with relevant values like 15, 25, 10, etc. Now come next. Assign different values to my box 2's instance variable. Now we are going to assign values to my box 2 also. Look, my box 2 dot width is equal to 5 semicolon. My box 2 dot height is equal to 10 semicolon. My box 2 dot depth is equal to 7 semicolon. Okay. So both my box 1 as well as my box 2 are properly initialized with the relevant values. Okay. With these assignments. Okay. You know, it's very simple. Now what we have to display the volume of first box. Okay. We have to display the volume of first box. My box 1 dot volume. This is the function, volume or method. See the syntax. Look at the syntax. Very, very peculiar syntax. If you are directly coming from a procedure-oriented language, you will be much surprised to see this syntax. See, the syntax is, we are calling the function or method in association with an object. Look, my box 1 dot volume, semicolon. Look, it is very special in object-oriented languages. In object-oriented languages, you are always making a call to a method or a function in association with an object. You have to do it like this, in association with an, but in the case of static, you can do it independently. We have seen so many static functions earlier in our discussions. So in static, there is absolutely no need for this compulsion. You can directly call the method. But as long as the function is not static, this is the typical syntax for calling a function in an object-oriented language. It is the same as in C++ also. C++ is one of the most versatile object-oriented languages, you know it. In C++ also, we are doing the same. That is object dot that function or object dot that method. See this. So that's why my box 1 dot volume, semicolon. Display the volume of the first box. Okay, fine. Next. Display the volume of second box. Again, my box 2 dot volume method, semicolon. So my box 1 dot volume method, volume function, we called. Again, my box 2 dot volume function or volume method we called. So both we called my box 1 dot volume and my box 2 dot volume, semicolon. Fine. After that, this is the closing brace. That is the closing brace corresponding to the main function, for the main function. That is the closing brace. This is the closing brace for the box demo 2 definition. The class box demo 2's definition is coming to an end at this point. Now the program is almost getting over, but we have to now come out with the definition of my box. See, we have used the class my box here. So that my box we have to now define. Now look, class my box. Then open the brace. So it has got instance variable first. Double width, semicolon. Double height, semicolon. Double depth, semicolon. Okay, it has got instance variables like width, height and depth of all are of type double. Okay. Now display the volume of a box. See, observe my box class contains function also. Like that, it contains a method also. So that is the difference between our previous box class and this my box class. My box class contains a method also or a function also. Look, void volume. See, the method's name is volume. It returns nothing void. Then open the brace. System.out.print in bracket. Volume is, then close the bracket, semicolon. Next line, system.out.print line in bracket, width star height star depth. That means width multiplied by height multiplied by depth. Close the bracket, semicolon. That means you are taking the volume. So width star height star depth is the volume of any geometrical object. You know it. So that means, so this is the volume method's definition. Close the brace. This is the closing brace for the volume method or volume function. This is the opening brace and this is the closing brace. Okay. So the method volume available in the class, my class, is fully defined at this point. It will simply print the volume. Volume is so and so. What is the volume? It will print. Volume is so and so. Okay, fine. Next, this is the closing brace for the class my box. My box class is now coming to an end at this point. The entire definition of my box class is coming to an end at this point. So that means everything is included. So this particular class, namely my box, contains a method also. That's very important point. So we have now added a method to the class box. So that's why I have just called it a different name, my box. Earlier in the previous program I was using class box only, but here I am using class my box. Okay, fine. Because this time the box class is a modification of the previous one. So okay, fine. Now everything is okay. Now look. You can save everything and you can click, you will get the output. Your volume is 3750.0, volume is 350.0. So box 1's volume is 3750, box 1's volume is 3750.0 and box 2's volume is 350.0. Okay, fine. That's all, simple calculation. Now look, some very interesting points I have noted down here. Please, now these comments you go through. Please note the following lines of code where the volume of the box is computed. Look, this is precisely the syntax for calling methods in object-oriented programming languages. Look, how we display volume of the first box. How? My box 1 dot volume, semicolon. Look, my box 1 dot volume. As I told you, the instance, the object dot function, object dot method, object dot method. You cannot just call the method alone. It has to be called in association with an object. So my box 1 is the object dot volume. Okay, fine. Semicolon. Next. Display volume of the second box. Look, again, my box 2 dot volume. My box 2 dot volume. Okay, fine. See, in object-oriented languages, a method invocation is always done in association with an object. That is, my box 1 dot volume or my box 2 dot volume. My box 1 dot volume method, volume function, or my box 2 dot volume method or volume function, full stop. We use the dot operator like this to make the method code. We have to use the dot operator like this. Box, that object dot method or function, fine. That's you keep that syntax in mind, always object dot method, fine. Now look, now again I am just keeping this point again, bringing this point to your attention. We have used a different box class here, namely my box. This time the box class contains a method too, a method also. That means it is different from the previous box class. So that's why to distinguish between the previous box class, simply class box, and this box class, namely class my box, I have used a different name, class my box, because this class is a modified form of the previous class. So, and as I told you the reason, I am using the same package. Since I am using the same package, there can be conflicts. If I am using the same name, there will be conflict. Otherwise, I have to use a again different package and put this program in that. Okay, it's absolutely not necessary. So what I will do is I just change the name of the class like this. Okay, fine. I think it's very, very simple. So again, we will save everything. We will just close. Volume is 3750.0. Volume is 350.0. Fine. The first, my box 1 is a bigger box. The my box 2 is a smaller box. Okay, fine. Now it's very, very simple. I think you go through the program 2-3 times. It will be very, very simple for you. Okay, fine. You will now come to an end. We are now considering a very similar program with some slight modifications. In the box class. Especially, that is specifically speaking, in the box classes method, namely the volume method. See, we are doing some small modification. Fine. So, for this program also we are using the same package, my package 06. And you know the mechanism of adding a new class in a given package, because we have explained it several times. So you are familiar with that concept very well. It's very simple a process. Now look, we are coming to the program. Look, package, my package 06 semicolon. The same package. Package, my package 06. Look, semicolon. Next, some comments I have put. Returning a value from a method. That's it. Look, while the implementation of the method volume does move the computation of the box's volume inside the box class where it belongs, comma, it is not the best way to do it. It's not the best way to do so. Yeah. For example, what if another part of your program wanted to know the value of wanted to know the volume of a box, comma, but not display its value. Just it wanted to know the value of the volume of the box. May not be for the purpose of displaying it. Okay, fine. A better way to implement volume method is to have it compute the volume of the box and return the result to the caller. Look, the following example, an improved version of the previous program, does just that. That's exactly what we are doing in this program. Comparing with the previous program, this is a slight modification because we are using here a return statement. So let us see how it is implemented. This is a more convenient method, so that it is available to other parts of the program also. The volume method's return value will be available to other parts of the program also. Fine. Now look, call this file as boxdemo3.java. So what does it mean? We are now going to create a class by name boxdemo3. That's it. Now look, public class boxdemo3. Public class boxdemo3. Then next line, open the brace. We are calling the main function. Look, public static void main in bracket string rs, close the bracket. Next, open the brace. Look, as I told you, here also this time I am making a different name for the class. The class name now is a box. Look, the box class name is now a box. And my box 1 is equal to new a box constructor, semicolon. Again, a box, my box 2 is equal to new a box constructor, semicolon. So please observe that we are now created a new class, class a box. So I have changed the name of the box class. As I have explained the reason why, because we are using the same package. So in the same package, if you are using obviously box, originally we used the class name as box. If you are using the same class name as box here also, there can be conflict. So the best way is to change the name of the class. So the previous program also, it was actually a different name. So each time when I am modifying the program, I am using a different name. Please observe. That's all the spirit behind it. So a box, my box 1 is equal to new a box, that is the constructor, semicolon. Again, a box, my box 2 is equal to new a box, again constructor, semicolon. My box 1 and my box 2 are the objects. Now, another variable by name wall of type double is also declared, double wall, then semicolon, fine. It is the same program as we did it in the previous, the same program. See, assign values to my box 1's instance variable. Assign values to my box 1's instance variable. We are actually assigning some values to the my box 1's instance variable. See, my box 1 dot width is equal to 20, semicolon. My box 1 dot height is equal to 40, semicolon. My box 1 dot depth is equal to 10, semicolon. Yeah, we have assigned different values to the width, height and depth attributes of the my box 1 object, my box 1 object. Okay, fine. Now look again. Assign different values to my box 2's instance variable. Here also we are assigning another set of values. See, my box 2 dot width is equal to 6, semicolon. My box 2 dot height is equal to 15, semicolon. My box 2 dot depth is equal to 7. Okay, here also another set of values we have assigned to my box 2's instance, its attributes like width, height and depth. Okay, fine. Now it's all very simple. Now get volume of first box. The volume of first box. You know the syntax, object dot method. See, my box 1 dot volume. It's assigned to wall, the variable wall. Wall is equal to vol. Wall is equal to my box 1 dot volume, semicolon. Then system dot out dot print line in bracket volume is plus wall, close the bracket, put semicolon, fine. Volume is so and so, volume is plus wall. So we have assigned the volume to the variable wall. Okay, fine. Next, again, get volume of second box. Again, wall is equal to my box 2 dot volume. Again, object dot method. Object dot method. The syntax is well known to you now. Wall is equal to my box 2 dot volume method. Then after that, the semicolon. Next, again, system dot out dot print line in bracket volume is, that much is with double quote, plus wall, close the bracket, semicolon. This is the closing brace. That closing brace is for the main functions. Main functions, closing brace has come here. After that, this is the closing brace for the definition of the class box demo 3. Box demo 3's definition is coming to an end at this point, or box demo 3's functionality is coming to an end at this point. Now what remains is that a box, the class has to be defined properly. Okay, class a box. The name of the box which we used here is a box. Look, the class a box. So now look, class a box, open the brace, double width, semicolon, double height, semicolon, double depth, semicolon. Okay, fine. Then look, compute and retain volume. Here's what we are doing. See, compute and retain volume. We are returning the volume value to the caller. Look, double, that is the return type, volume, return type. Then open the brace, return width star height star depth. That's all. The multiplied values of width and height and depth is the return. So return width multiplied by height multiplied by depth. That is it. Return width star height star depth, semicolon, close the brace. Close the brace. Now that function is also properly defined. Then this is the closing brace for the class A box. This is the closing brace of the class A box. Look, I have put a small comment. Each time we have used different names for the box class. Each time we have used different names for the box class. You know the reason I have explained. Okay, fine. Now look, it's very simple. Now we will just save everything and then we will click this icon, run icon. Yeah, volume is 8000. Next, again, volume is 630.0. 8000.0 and 630.0. Volume is 8000.0. Volume is 630.0. Yeah, you know, the first box is a bigger box. 20, 40 and 10. So it's a bigger box. So next box is a smaller box. So first box volume is 8000.0 and second box volume is 630.0. Okay, fine. It's a very, very simple program. So you please understand the difference. Look, we have just made the method return a value, return the result, return. Fine. That's all the difference. Okay, I think you will just come to an end. Yeah, in this program, we are using the so-called setter methods or setter functions. Let us see how to proceed. Look how this is done. As you know, we are using the same package. My package 06. For this program also, we are using the same package. My package 06. You know the process of creating a new class in a given package. That is well known to you. I don't have to again and again discuss that. Okay, now we will go into the program. Look, package, my package 06 semicolon. Some comments I have put. Look, we can also use setter methods in bracket, or let us call it as setter functions. Okay, either setter methods or setter functions to set dimensional values to the box object as under. Dimensional values can be set using the setter method or setter functions, as we are doing it in the following program. This program uses a parameterized method. A parameterized method. Okay, fine. Call this file as boxdemo4.java. What is it? Boxdemo4.java. What does it mean? We are now going to create a class by name boxdemo4. Look, next line. Public class boxdemo4. Boxdemo4. Next line, open the brace. We are calling the main function. Look, public static void main in bracket string, then args, close the bracket, open the brace. As you know, this time I am using again a different name for the box class. This time I am using the name bbox. 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 My box 1 is equal to new bbox, that is the constructor, semicolon. Again bbox. My box 2 is equal to new bbox, again constructor, semicolon. So this time we are using the class called class bbox. The name of the class is now bbox. Earlier it was abox. Okay. As I told you, every time I will be using a different name for the box class. Okay. So bbox, my box 1 is equal to new bbox constructor, semicolon. Bbox, my box 2 is equal to new bbox constructor, semicolon. Next. One variable by name wall of type double wall, semicolon. Look, initialize each box. Now we are going to initialize each box using the setDim function. So setDim function is for the set dimension function. Set dimension function. So my box 1 dot setDim in bracket 10, 25, 18, close the bracket, semicolon. Next, my box 2 dot set dim in bracket 4, 5, 12, close the bracket, semicolon. So each box will be initialized with these given values in the bracket. So whatever values we have given in the bracket, it will go to the respective attributes of the class object. So my box 1 dot set dim for setting the dimension. So set dim in bracket 10, 25, 18, close the bracket, semicolon. Again, my box 2 dot set dim in bracket 4, 5, 12, close the bracket, semicolon. Fine. We have used this function set dim. Now look, get volume of the first box. Now we have to get the volume of the first box. Like, yeah. So for that we are using my box 1 dot volume. Then after that, semicolon. Its return we are assigning to wall. Its return is assigned to wall. So wall is equal to my box 1 dot volume. You know the syntax. Here also the syntax is well known to you. Object dot method or object dot function. Here also object dot method or object dot function. My box 1 dot volume, semicolon. Next. System dot out dot print line in bracket volume of my box 1 is, that much is with a double quote, plus wall, close the bracket, semicolon. So the volume is calculated and it is getting printed using the print line function. Again, get volume of the second box. Get volume of the second box. Again, my box 2 dot volume semicolon. Its return is now assigned to wall again. Now wall is getting assigned with the volume of my box 2. My box 2 dot volume. So again, object dot method or object dot function. This is the mechanism of calling the function. So this function's return is assigned to wall. So now wall contains the volume of my box 2. Okay, then next system.out.println in bracket. Volume of my box 2 is with that much is with the double quote plus wall. Then close the bracket, semicolon. Fine. Then this is the closing brace for our main function. Void main, that is static void main. The main function is coming to an end at this point. Next, this is the closing brace for the functionality of box demo for class, or box demo for classes definition comes to an end at this point. Okay. Now what remains is only defining the B box class. As you know, we are now using the box called B box. So we have to now define B box. Okay. Class B box. Open the brace. Double width semicolon. Double height semicolon. Double depth semicolon. So the attributes of the box. Any object will be having these attributes. So this is the instance variables like width, height, and depth. Okay, fine. Next, compute and return volume. Compute and return volume. Yeah, you know that function very well. Double volume. Volume. Its return type is double. Open the next line. Open the brace. Return width star height star depth semicolon. Fine. We are multiplying width with height and depth. So width star height star depth semicolon. Close the brace. This will return the volume of the so-called box. See, there are two boxes, my box and my box 2. So this is actually, it will return the volume of the given, whatever box you want, its return. Its volume will be returned with this volume function. With this volume function, we are getting the volume of the given box. Okay, now look. Sets dimensions of box. Now we are using this following function to set dimensions of the box. Void set dim. That is the function, set dim. We used that function already. See here, my box 1 dot set dim. We used that function. Now its definition is like this, set dim. Void set dim in bracket double w comma again double h comma double d, close the bracket, open the brace. Width is equal to w, height is equal to h, and depth is equal to d semicolon. Width is equal to w semicolon, height is equal to h semicolon, then depth is equal to d semicolon, close the brace. This is the closing brace for the set dim function. Now this is actually the closing brace for the class B box. B box class definition is coming to an end at this point. So the entire program is now over. So when we are actually, yeah, it's very simple. This is a very simple program. My box 1 dot set dim. So set dim is now, look, it is actually, we have passed arguments like 10 comma 25 comma see 18. Fine. Okay, fine. It's very simple. So value of 10 will go and get assigned with the width part. It will go and it will get assigned with the width part, and 25 will go and get assigned to the height part, and again see this 18 will go and get assigned with the depth part. You know the process of how that function works. So it's very simple. Now everything is coming to an end. Fine. It's a matter of just running the program. So we will just save everything. We will save everything. Now we just click this. See, volume of my box 1 is 4500.0. 4500.0. Then volume of my box 2 is 240.0. As you know, this first one was a bigger box. 10, 25 and 18 is the dimensions. So its volume is 4500.0. Again, the other one, its dimensions are small, 4, 5 and 12. So its value is 240.05. So that's it. Volume of my box 2 is 240. Yeah, so you just see, it's very simple. We have used the return function as well as the set dim or set dimension function. That particular function is called setter functions or setter method. It's called setter method or setter function, which actually sets values to the object, which is used to set values to the object concerned. Okay, fine. It's all very simple a program. We will save everything. We will run once again. See, volume of my box 1 is 4500.0. Volume of my box 2 is 240.0. See, 4500.0, 240.0. Why the point? It is actually it's all the volume is in double value. It's a double value. So that's why the 0.0 is there. Okay, now it's very simple. Absolutely, there is nothing great in this program. This is a sort of a repetition of the previous program with slight modifications. But you please again keep the point in mind. See, we are again using a different name for the class. This time we used B box. Okay. I have explained the reason for that and all that. Okay, now we will come to an end. Yeah, constructors. We are coming to the topic of constructors. Okay. A constructor initializes an object immediately upon creation. Full stop. It has the same name as the class in which it resides and is syntactically similar to a method. Once it is defined, the constructor is automatically called when the object is created, before the new operator completes. Full stop. Constructors look a little strange, because they have no return type, not even void. Full stop. This is because the implicit return type of a class's constructor is the class type itself. It is the constructor's job to initialize the internal state of an object so that the code containing an instance will have a fully initialized, usable object immediately. Constructor is a special type of method which is used to initialize the object. Every time an object is created using the new keyword, at least one constructor is called. It calls a default constructor if there is no constructor available in the class. In such cases, the Java compiler provides a default constructor by default. There are two types of constructors in Java: no argument constructor, and parameterized constructor. What is it? No argument constructor and parameterized constructor. Yeah, now we are discussing what is called Java default constructor. There are two types of constructors. One is the default constructor and the other is parameterized constructor, or default constructor or no argument constructor. Actually, it's also called no argument constructor. Look, we are using the same package, my package 06 here also. Package, my package 06 semicolon. Then look, let us just go through the program. See, this is also created in the same package 06. You know how to create a new class in a given package. Go to new, come down to class. Here you keep. Actually, I have used the class name as bike. You type bike or whatever you want. And don't forget to click this public static void main string args. That also must. Okay, I'll just close it. You know it well. So package, my package 06 semicolon. Look, Java default constructor. Look, a constructor is called default constructor when it doesn't have any parameter. When it doesn't have any parameter, it's called a default constructor. Syntax of default constructor. Look, class name, then a pair of parentheses, After that, a pair of braces like this. Syntax is very simple. Class name, then a pair of parentheses. After that, a pair of braces. Okay, now look, next. In this example, we are creating the no argument constructor in the bike class. We are using a bike class. It will be invoked at the time of object creation. So the constructor will be invoked at the time of object creation. That's the most important point to keep in mind. At the time when the object is created, automatically the constructor is invoked. Look. Java program to create and call a default constructor. Java program to create and call a default constructor. Look. Call this file as bike.java. What is the name of the file? Bike.java. What does it mean? We are now going to create a class by name bike. Yeah, fine. Look. Public class bike. The name of the class is bike. Hence the file name is bike.java. So public class bike. Then open the brace. Next. Creating a default constructor. Now some comment I have put. Creating a default constructor. Look. This is the default constructor bike followed by a pair of parentheses. Bike, left parenthesis and right parenthesis. Next, open the brace. We simply put system.out.println in bracket. Bike is created, exclamation mark. That much is within double quote, close the bracket, semicolon. Then close the brace. Very simple, bike constructor. It just prints system.out.println, bike is created. Okay, fine. Close the brace at this point. Now comes the main function. We are calling the main function. Public static void main string args. Our main function. Public static void main in bracket string args, close the bracket. Next line, open the brace. Now look, we are now calling the default constructor. When the default constructor comes, when we create a new object. How we are creating an object? Using the new keyword. Look, see, bike B is equal to new bike. The new bike, the constructor, put semicolon. Look, bike, that's the class name. B is the object, is equal to new bike constructor, semicolon. Bike object B is created with the new keyword. Okay, then close the brace. Then close the brace for the main class. The definition of class is coming to an end at this point. See, this is the closing brace for the definition of the bike class, or the functionality of the bike class is coming to an end at this point. It's over now. Look. See, now look, everything is over. Now we will just click this run icon. Look. See, bike is created. Look. See, when the bike object B is created, the constructor is invoked, hence the output. So, at the moment when the bike object B is created, the default constructor is invoked. Hence, the output. Output is bike is created. Look, bike is created. System.out.println in bracket, bike is created, exclamation mark. Look, bike is created. It's that very simple. Now we will come to an end.